solve another Leetcode problem, 233, number of digit 1. So the problem is straightforward. We are just giving a number and we're gonna count how many digit ones for the number which is less than and equal to this number n and more than and equal to 0. So this means for this 13, let me just give you an example. So for this 13, we're gonna count how many ones. We have a 1 and 1 to 9, there's still 1, but 10, 11, 12 and 13. And for this, so for those numbers, how many ones? So that is 1, 2, 3, 4, 5 and 6. So we're gonna return 6. So the first method is gonna be the brute force, but the brute force will be time limit exceeded. Let's just try the brute force first. So for I in range, we're gonna start from 1 and n plus 1. We just count the result. So we're gonna have a result would be equal to 0, and result should plus equal to string I dot count how many of string ones. And finally we just need to return this result. This is the basic idea to solve this problem. So if this number n is just a very small number, it should be okay. But what if this number n is too big, like 10 to the power of 9? It will have problems. Now I have time limit exceeded because I have a number that is so big. As you can see that if I delete this testing case, let's try to test it again. As you can see, it works for some of the numbers, but it will be time limit exceeded. Let's just try. That is because this is just a brute force, and the time complexity, as you can see, it will be very big. So this number maybe here is 10, and here is n. 10 times n, it will be, so this is for this number, it will be time limit exceeded. So the time complexity will be 10 to the power of 9 times 10. Basically how many ones inside 10 to the power of 9, it will have 10. So it will be 10 to the power of 10. So that is why it will be time limit exceeded. Now we're gonna use some clever ways to solve this problem. So that is called digit DP. So for digit DP, it is a template problem. Let me give you just an example. So for example, we have a number like 1, 2, 3, 4, 5, 6, 7. We have a number like this. But for the brute force and the straightforward way is we just need to count how many ones for each of the numbers. But that will take a lot of time. Now we're gonna use some clever ways. So for the digit DP, we're gonna count how many ones at each of the digital position. So for example, we have some other numbers like XX. We don't know what it is, but here, for example, we're gonna check how many ones at this position. So for this number, it has 6 digits, and for the digit at this position, this is a 1. So we're gonna call the digit positions. So the first place, so this place, so it is the digit. We're gonna call it digit 1. Maybe here is the digit 10 and digit position 100, and here is 1000, 10,000, and 100. But for the digit at this position, so this is a 1000 position. So we're gonna count how many ones at this position. We're gonna have some different ways to analyze. So for the first thing, so this 1, we will ignore this 1. We just check at the left side and the right side of this 1. If at the left side, how many possible ways? So this is a 23. So we will not use 23, because if we use 23, we're gonna analyze this number. We're gonna compare it. If it is more than 1, equal to 1, or less than 1, we're gonna need to analyze. But what if we just count the numbers from 00 to 22? We just count the numbers from 0 0 to 22 at the left side of this one. Yeah, it means at the left side of this 4. So how many ways? So there are 23 ways. Yeah, so in total there will be 23. Yeah. Now we're gonna count at the right side how many possible ways at the right side. Yeah, because at the moment we only count at this position for this ones how many possible ways. Yeah. So at the moment we don't need to consider this 4. So how many ways? It's gonna be starting from 0, 0 to 990. So how many ways? It will be 1000. So the final result would be 23 times 1000. So this is the easy case. So we don't need to consider this 4 with this 1. Yeah. So yeah, this is the first case. So I'm gonna call it the first case. Yeah. Now we have a second case. So what if this number? Yeah. What if our number is not 4? For example, our number maybe it is 0. Yeah. So what if this number is just 0? So this is gonna be the second case. Yeah. So this position gonna still be 1, but here it is 0. Yeah. So if it is 0, it means it is not possible. Yeah, because we're gonna count how many ones. Yeah. But if this is 0, this 1 doesn't meet the condition. Yeah, because if this is because for the first case, this 1 is less than 4, it is okay. Yeah. But if this is just 0, we will not count it. Yeah, because we just count how many ones at this position. Yeah, it is not possible for the 0. Yeah. Yeah, because for the first position, this one must have a 0. It is possible because 1 is less than 4. And then we're gonna check all the possible cases. Yeah, but for the second case, this is 0 is less than 1. It is not possible. Yeah. Maybe you think you will count other possible ways. This is 1, maybe this is 22, but this is not what we are analyzing the problem. We will not analyze it like that. We just analyze for each of the position. Yeah, so if it is less than, yeah, so if this number is 0, it is less than 1, it is not possible. Yeah, but what if this number is but what if this number is 4? So this will be the second case. Yeah. So for the second case, because for this one it will always be possible, we already counted, and for the second case we're gonna count for this 4 if it is more than 1. Yeah, so we are sure this is possible. And from the left side, and how many possible ways? There's only 1, because from 0, 0 to 24 we've already counted. Now it only has 23, so we have 1 ways. Yeah, so it means 1 times. And for the left side, yeah, we still need to check how many ways. So it's gonna still have 1000 ways. Yeah, so it means from 0, 0, 0 to 999. Yeah. Yeah, as you can see, yeah, this is 1, and from here it is always possible. Yeah, so this is the second case. And for the third case, so for the third case, it will be something like this. Let me make a copy. So here will be the third case. We still have this number, but this digit will be this digit will be 1. So if it is 1, we only count how many possible ways. it is a 567 plus a 1. This one means it is a 0. Yeah, so how many ways? It's gonna be 567 plus a 1. Yeah. So this is for analyzing the problem. According to the different cases, we're gonna have the different count. Yeah. Now let me try to code it up from here. So first of all, we're gonna turn this number into a string, and now we're gonna count the length. We're gonna check the length of the string. It's gonna be the length of the string. Now we're gonna have a result. So this is what I needed to return. So for the result from the beginning, it's gonna be 0, and finally I just needed to return this result. Now I'm going to count it. Yeah, so I'm going to count it from 1 to n plus 1. This is just easy for the calculation because this is a digital DP. Yeah, we're gonna use some tricks to calculate for each of the digits and how many different ways. Yeah, we're gonna basically check three different ways to count how many different cases. Yeah, so for some of the case, maybe yeah, for example, this is a 0, and yeah, if let me put it like this. Yeah, so if this digit is 0, yeah, definitely we are sure. And for the number, yeah, if this is a 0, but currently we're gonna count how many ones at this position, because at this position it is a 0, but we need to count how many ones at this position. So it is not possible because this position is 0. Yeah, but we need to count ones. So definitely at this position, it is not possible. Yeah, you can imagine. Yeah, you can imagine the situations. Yeah, like this. Yeah, because this one is a 0. So how can you count ones at this position? So it is not possible. Yeah, if it is a 1, so definitely we can count it. And this number we're gonna count it as 1, maybe here, and maybe left side and right side, we can still count it. Yeah, but if this number is 0, how can we count the positions? We cannot count it, so it's gonna be 0. So this is gonna be the last case. Yeah, so let me put it here. Yeah, but I'm gonna still put it here, but we will not code it up from here because we don't need it. Yeah, so if this digit at this position is just 0, we don't need to count it. Yeah, and there's no duplicate because we only count the ones at each of the positions, because we count the number of ones. We don't count how many numbers. Yeah, we only count the number of the digit. Yeah. Now let me do some preparations. I'm gonna prepare two variables, high and low. High means the high bit. Basically, it means at the right side. Yeah, and this bit will be the high numbers, high bit numbers, and the low variable, it means just the low bit numbers. Yeah. So I'm gonna prepare a high and low variable. Yeah. So for the high, it would be, yeah, let's check the high. It's gonna be n divided by power of 10 to the power of I. Yeah. So for example, at this, yeah. So for example, for this digit at this position, we're gonna count the high bit. So this n is yeah. Let me use the capital N. It is a capital N. So the capital N is 6 for this string. Yeah. 6 divided 10 to the power of, yeah, so for this bit it is 4, because from here this is 1, 2, 3, and 4. Yeah, so 10 to the power of 6 divided by 10 to the power of 4, it is 100. Yeah, it means just for the high bit there's 100. Yeah, yeah, for the high bit, it is not 100, so we need to use the lowercase n, because this number is just like this number divided by 10 to the power of 4, so we're gonna have 23. So now we need to use this 23, because from 0 to 24 there are 23 numbers. Yeah, and for the lower digits we're gonna use power of 10 to the power of I minus 1. Yeah, so if this I is 4, I minus 1 is 3, 10 to the power of 3, it is 1000. It means, so for this number, at the left side, it's gonna be 1000, just from 0 to 999. Yeah, so there are 1000 possible cases. Now we just put it into the result. It's gonna be the high times low. Yeah, now we're gonna check the testing case for the second case and the third case, because we don't need to consider the fourth case. Yeah, so for the second case we're gonna check this digit. If this digit is equal to 1, if it is equal to 1, yeah, we're gonna count it like this. Yeah, if it is more than if it is more than 1, we're gonna count it like this. Yeah. And how do we check the digit? So the digit would be n minus I. Yeah. Here is just a little bit mathematics you need to consider. And this n is 6. 6 minus this position I is 4. It is 2. So 0, 1, 2, it is this digit, right? Yeah. Now it means it is this digit. If it is equal to character 1, so yeah, let me check if it is equal to let me put it 4. If it is more than 1, let me analyze the more than 1 first. Yeah, if it is more than 1, so this is gonna be a 4, and this is my result. So it is just 1000. Yeah, like this. If it is more than 1 for this case. Yeah, because for this one we will not count it. We only count at the left side how many possible ways. Yeah. So yeah. Yeah, this is the first case. The second case, yeah, I think I confused a lot of testing cases. Let me put it here. Yeah, so for the second case, if this is 1 and this is 4, and there will be 1000 testing cases. Yeah, so for the 1000 testing cases, we just need to use the result plus this 1000. So this 1000 gonna be the low. Yeah, so elif s n minus I equal to this character 1, so the result would plus equal to the last case. So it's gonna be 500, and 67 plus 1. And how can we count it? It's gonna be the number n divided by low plus 1. Yeah, this number n is just this number. Yeah, it is just this number. This number divided by low is 1000. It is 567 plus 1. It is the final result. Yeah. So this is the entire code. If everything is right, I think. Yeah. Let me just check it. There's something wrong with this testing case. Yeah, let me check it. There may be something wrong. Yeah, now let me use this one to check. Use this number to check. Maybe it's easier for me to use this number. Yeah. I'm gonna check the first result. Maybe. Yeah, this number is right, as you can see. Yeah, it means basically my function should be okay, but the 13 is not okay. Yeah, let me check why the 13 is not okay. This 13 is not okay. So for this 13, yeah, this is n, this is high, and yeah, so here yes, I equal to 1, I have one possible result. When it is equal to 2, I have 2. It is wrong. Yeah, this is high and this is low. Let me print it from here. Yeah, this is 2 and this is 4. Of course it is not right. Yeah, I forgot if it is modular or if it is a modular this 1000. If this n modular 1000, yeah, I think it should be modular. I don't know. If it is modular this low, what I got. Yeah, if it is modular, I got this one. If it is divided, yeah, I think it is modular. It is modular. Yeah, if I divided it, it should be wrong. I think it should be modular. Yes, let me. Yeah, I did something wrong from this line. Yeah, because this last line, this line is just means I need to get this number 567. It should be modular. If I use divide, I didn't get the right number. I just get the other part. Yeah. Now let me just test again to check if it can pass all the testing cases. Yeah, let me delete all this line and submit again to check. Yeah, as you can see, it works and it's pretty fast. So here I made a mistake. Yeah, so for such a digital DP, it's really easy to make mistakes. I hope you will not make such kind of mistakes. So here I should use a modular, but instead I used a division. So I guess it takes me a lot of time to fix this bug. And the time complexity is just on. As you can see, for this kind of calculation, we didn't consume much time, and this n is just the length of the string. As you can see, if you can think of the problem by using the digital DP, normally you don't need to consider the time because it will always be works. You only need to consider how to write